Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello, and welcome to this presentation of the International Mechanical Code. My name is Thomas, and in this presentation, we're going to look at Chapter 10, which is about boilers, water heaters, and pressure vessels. So grab your books, open up to Chapter 10. Let's get started. All right, before we get too deep into this, let's talk for just a minute about what is the difference between a boiler and a water heater and a pressure vessel. A lot of times these terms are used interchangeably, and the reality is the water heater and boiler basically do the same thing, right? Both the boiler and the water heater apply energy to heat water to either heat space or provide hot water. These are very similar in function. In fact, even manufacturers will build them with many of the same components, but there is a difference. And in order to really understand this, let's go back to Chapter 2 of the International Mechanical Code and look specifically at the definitions in that chapter. The definition of a water heater, for example, is any heating appliance or equipment that heats potable water and supplies such water to the potable hot water distribution system. Couple of key words here: potable hot water. This is an open system, meaning water passes through it, it's heated, and it goes on and is used at the fixtures. So potable water is the key when we're talking about water heaters, generally, right? You can use a tank-type water heater to heat space. And so then, is it a boiler? Not so much. But generally, water heaters heat the potable water, right? Compare that with the definition of a boiler. A boiler is a closed heating appliance intended to supply hot water or steam for space heating, processing, or power purposes. Notice, boilers are not just about heating water for potable water use, like your faucets and showers and other fixtures. It's mainly about heating space. Boilers create hot water or even steam to be able to transfer BTUs into the space and heat the space. That's mainly what boilers are all about. Now, can boilers be used to heat potable water? Yes, they can. We can have heat exchangers, or they can even be an open system that pass water right through. Please don't get confused here. We're generalizing. Water heaters are for potable, open systems, and boilers are for closed systems that are used for heating space, generally, right? There are also in this definition some more specifics about the difference between low pressure and high pressure boilers, but let's just stick with the basics. Now, how does a pressure vessel differ from a water heater or a boiler? Let's look at the definitions. A pressure vessel is closed containers, tanks, or vessels that are designed to contain liquids or gases or both under pressure. That opens up a wide variety of possibilities here, right? But a lot of times these mechanical systems will have a holding tank in addition to the boiler so that there is a reserve of hot water. That's one example of a pressure tank. Now, when it comes to any of these, they all have one thing in common. They're dangerous. Yeah, because what we're doing is we're adding water and heat, often fire, putting it in metal, adding electricity. What could possibly go wrong? There are a lot of things that can go wrong in that scenario, in that mixture of elements and equipment. And so we have to use extreme caution so that we don't blow ourselves up, or blow up our dwellings, or hurt people we care about. This chapter is largely about maintaining these water heaters and boilers and even pressure tanks in a way that keep them safe. Unfortunately, this chapter was developed after having had a long series of unfortunate events involving boilers and water heaters. We've come a long way in the last couple hundred years. This brings us to the very purpose of International Mechanical Code Chapter 10. And this is spelled out right at the beginning of the chapter. It states, this chapter presents regulations for the proper installation of boilers, water heaters, and pressure vessels to protect life and property from the hazards associated with those appliances and vessels. So we can trust that as we learn this chapter, we will be knowledgeable on how to run these appliances, these boilers and water heaters, and to do it in a safe way. We'll start at 10:01, and this gives us the general. This chapter is all about the installation, alteration, and repairs of boilers, water heaters, and pressure vessels. That's what it's going to give us. Let's look at 10:02, which focuses on water heaters. It says specifically that water heaters must be listed and labeled. Listed meaning that they meet certain manufacturer standards and that is labeled on the appliance itself. They must be installed according to manufacturer's instructions. Now, more than any other chapter, I think this is so applicable because they could write an entire book about how to install a water heater or a boiler, but the manufacturers already did that. Yeah, so as they're writing code in this chapter, they very often repeat the requirement to follow the manufacturer's installation instructions. Why? Because the manufacturers already wrote the book. And we don't have to rewrite the book as long as we say, do what they say. There you go. Now there's another line in here that kind of goes without saying, but unfortunately, throughout history, people have not really thought things through when they were putting buildings together. And I don't know why you would think that it's okay to build walls all the way around a water heater so that you can't get it out. But the truth is, people do that, or have done that. I know because I was a service plumber, and there were sometimes it was near impossible to get the water heater out of there for a replacement. But that brings up a very important point. Water heaters and other appliances are not going to last as long as the building. So we always have to be thinking about how are we going to repair or replace this, and building frame walls around it so that you can't get it out is not thinking very well, is it? No. But they put that in here because it's happened. Here's an example that's all too common. The door to this mechanical closet is big enough to get the water heater in and out. Until you put a furnace in the same closet with it, and once they're in there together and all hooked up to ductwork and pipes, and you can't get it out anymore. It's very difficult without removing structure of the building, walls, doors, whatever else, right? I will pause here to make a quick comment on the installation of water heaters. What's the difference between someone who is a professional and someone who is not? Well, first of all, the professional knows the code and makes sure that it's installed according to code. That should be you, and that should be me. But there's another telltale sign as to whether you're a professional or not. And this has to do with how you play with your local jurisdiction. What I'm referring to is the requirement in some areas for you to get a water heater permit to replace a water heater. You know, we get permits to build buildings. Of course, we do that. You should be getting a permit when you remodel a building. But who gets permits when they replace water heaters? If that city or county jurisdiction requires a permit, as a professional, you should do it. Why would you not do that? Why would you think I'll just swap this out and it doesn't matter because I'm going to do it like this anyway? You know what really happens? And I know this is true. If they require a permit and the plumber decides not to do the permit, guess what? They cut corners. Oh, yeah. Because who's going to see, right? Who's going to know if I don't bring this all up to code on the replacement? They're like, let's just make this quick, take our cash, and get out of here. That is unprofessional. And I'm calling those plumbers out. You don't need to be that sort of unprofessional. Do it right. If you're going to be a good plumber, be a good plumber. Play by the rules. Charge for it. If I'm going to do a permit, I charge for it. I charge the customer for it, and I make some money on it. It's not that I don't have to make the money, but I am going to do it right. All right, back to the matter at hand here. We're looking at 1002.2, which is water heaters utilized for space heating. You can use water heaters, obviously, to heat potable water, but they can also be used to heat the space. If a water heater is used for both, or even if it's just used to heat space, then we must install a water heater that's capable of doing that was manufactured for that purpose. If you take a standard tank-type water heater and throw it into a space heating situation, it doesn't have enough BTUs. That's the truth. You can get that 40 or 50-gallon tank with a 60,000 BTU rather than a 40,000 BTU when you're heating space, and that's what you need. You need to be able to crank out those BTUs, because here's what you don't want. Throw in a 40,000 BTU standard tank in a space heating situation, and then you don't have enough hot water for your fixtures, or you don't have enough hot water to heat the space. Then you're in trouble. Who's going to want that? Then you're going to be eating a water heater. So you got to make sure that if you're going to use it for space heating, that it's made for that. Also keep in mind that there are temperature limitations. You might have to crank that water heater up to 160 or more to be able to create enough heat in the space to transfer those BTUs in the living space. But 160 is way too hot for your potable water. So you have to temper it down. The hottest you can go on the potable water side is 140, which, by the way, is already really hot and easy to scald. Anything more than 120 degrees Fahrenheit, you increase that chance of scalding. So you get up to 140, it's pretty hot, but definitely not more than that, right? Code says if you're going to use this water heater for both and you need to crank up the heat, then get a mixing valve and temper that down so that your fixtures, your faucets, your shower, all of that have that lower temperature and people are not going to get hurt. Moving on to 1002.3, supplemental water heating devices. Supplemental meaning that you're bringing in heat from something else just to help out. Here's an example. If I have some solar collectors on the roof that I can use to heat water, and I can transfer that hot water down to my water heater, that can supplement or help that hot water so that I'm not relying just on electricity or gas to heat it. I'm bringing in another source that doesn't cost as much. This paragraph says potable water heating devices that utilize refrigerant to water heat exchangers shall be approved and installed in accordance with the International Plumbing Code and manufacturer's instructions. So refrigerant to water means if you're going to cool something off using a refrigerant, you have to remove BTUs and put them somewhere else. Wouldn't it be convenient if you could take those BTUs you're pulling heat out of the refrigerator and put those into something that you want to heat, like your water heater? That's the supplemental exchange, and you can do that. But you want to make sure you're not having any problems with crossover, so the International Plumbing Code would dictate backflow prevention, and the manufacturer's instructions are going to help you get all that system right, because to me, that sounds a little more complicated than hooking up a water heater. One last section before we leave 1002. This is a new one in the 2024 code, so if your jurisdiction is not enforcing this yet, well, just know this is probably coming in the future. But it makes perfect sense. We should be doing it anyway, and here's what it is. Water heater pans, right? We put a water heater pan under any other tank in the potable setting. Why wouldn't we do that if we're using it for space heat or something else, right? So if it's a water heater and it should have a pan, then we should put it in. And that's what they've added here is they say, let's just go look at International Plumbing Code Chapter 5, look at Section 504, and do what they say about pans, because we don't need to rewrite this, but we should be putting pans in. So there you go. Section 1003 gives us more information specifically about pressure vessels. It states that they have to meet the ASME standards. We should be following manufacturer's installation instructions, as we've talked about before. And there are other nationally recognized standards that may have to be applied to these pressure vessels. 1003.2 talks about the piping. Think about this for a minute. We put a lot into the manufacturing of water heaters and boilers to make sure that they're able to hold that pressure as we're heating up water. But what about the rest of the components? What about all the pipes that are connected to that system? What about the pressure vessel itself? Are those also capable of handling the heat, the circulation, the vibration, all of that wear and tear? What I'm coming to here is that the piping, or the components that connect all of that system together, those might be the weak link. Those might be the parts that end up with a catastrophic fail. Big, dangerous damage. So we want to avoid that. And for that reason, all the piping, all the components, everything involved with these pressurized heated systems have to be able to handle all of that pressure and stress and high temperature. So they also have to be rated to the same level. 1003.3 gives us a specific standard for those pressured vessels. Many pressure vessels are just metal that's been shaped and welded together. And that welding is going to be the only thing keeping that pressure vessel from exploding. So it also has to meet a high standard. It's called the R stamp. Those who are working on welding on these tanks have to be a R stamp holder, or they've met that approved standard in their skill at welding. Tanks would have to meet the National Board Inspection Code Part 3. Honestly, I don't know much about that, but let's just say it's a high standard for the tank and the weld. And they would need to receive the R stamp, kerchunk, which makes it very visible that this weld met that high standard and should be able to hold under pressure. At this point, we have discussed the International Mechanical Code Chapter 10 from Section 1001 to 1003. In the next video, we'll move on and we'll start with 1004. We'll talk about boilers, boiler connections, and safety devices and controls. I'll see you in the next presentation. Wait, where's my thing? We're recording and I'm supposed to have a slideshow. Beep.